Okay, hello everyone. This is the first video lecture for Chapter 2 in EE160, and the class is Programming for Engineers. For those of you who have been on my YouTube channel, you will see there's Chapter 2 for EE160 from last year. The YouTube lectures are good content. They actually closely parallel the book that I've chosen for this year, but I don't want you to be confused if the examples don't match the examples of the book. But there are some really good examples in those YouTubes, and you are free to watch the YouTubes from last year as well. Some things I didn't like about last year's textbook, which is why I made so many YouTubes, is that the book we had last year, even though it was a Programming for Engineers book and used more mathematical examples, but the thing I didn't like about it is from a programmer's point of view, it wasn't very rigorous in programming standards. But anyway, they are good examples. I tried to compensate for the book that I had last year. So anyway, first part of this thing is mentioning that we are going to be using my programming lab. I'm going to I have it open right now, so I was going to pull it up and show it to you in case you haven't played with it yet. Maybe I don't have it up right now, so let's... Gee, no. Okay, we'll go back to that part. Actually, I will cut off this part of the video. Ah, here he is. Never mind. I won't cut off this part of the video. I just don't quite fit here, so let me change the size of my screen to fit. There we go. So, nope, not quite. So, my programming lab, once you sign in, let's go to my course. Once you sign in, you will see your course to load. If you have more than one course from Pearson, you might have more than one course to choose from. So once you are in the course, you will see a table of contents on your left. It goes through each chapters. We are starting Chapter 2 right now. I like these exercises. They're nice, but they're not the same as doing a complete program. They do build up and give you lots of material when we'll use it, but they are sort of the intermediate practice before getting to the full up program. For example, if I click on this one, there's really nothing there, but I click on the next one, and the problem statement says, write a statement that prints hello world to the screen. And then you go down below, and I actually did it. I typed it in and said I printed hello world to the screen. Well, let's mess it up. Let's say I messed up. So I submit this answer, and I had errors. I didn't do it right. So I come back down here, details. Tells you a few things. It gives you advice. My view is a little bit big here, so it's messing up. Your program did not write the message specified, it told me. So it tells me some hints on how to fix it. So I'll go back to my work area. I got it wrong. I'm going to fix my submission. Submit. And yes, I was correct. My submission was correct. So you get the idea. These are the... Now it asks you to write a complete program. Type your solution here. Mine says acting itself as self because I'm an instructor here and I'm being myself doing it. So I'm going to be assigning various problems out of this. I think it's fairly intuitive about what's assigned. Actually, some of the problems that are in here, I just need to make sure that I show that there's extra practice problems and there's problems that I'm asking you to do for a grade. And I will let you know a little bit further on that. Right now you have access to absolutely everything and nothing is being graded. When you submit your answer, if you don't get it right, it's not going to give you the correct answer. And if you can submit it 10 times if you want until you finally get it right. And it builds progressively. It's a very nice way to practice your programming. I like it. And eventually you'll get the answer right, and then it will tell you what the correct answer is, but you already got it right, so great. I may set some problems up where you get 3 tries to get it right, and then I'll give you the answer so that you can just learn from it. But anyway, more on that coming up. So let's get rid of my programming lab right now. This is a further out view of it. So in Chapter 2, you're going to write more simple programs, only you're going to learn about really what every line in your code is doing. You're going to learn to give your programs input and output statements. You're going to learn about the fundamental data types, memory, beginning of learning some memory concepts, how the program is stored in memory, arithmetic operations, our first if statements and controlling the program, and then we'll have some notes on first comments on making our programs be secure, because as you know, programs and applications that you develop may be vulnerable to being compromised by somebody malicious, and you don't want that to happen. So moving on. So let's go into the first section. Before we do, I'm going to say a few things about the C language. I hope on Laulima you read the little article I posted on why you should learn the C language. First of all, one reason you should learn the C language is it's been around a long time. It's very standardized. Matter of fact, it's defined by this international ISO IEC standard, commonly referred to as the C11 standard. There are some older standards for it, like C99. You can guess that was 1999, but C11 is the standard for 2011 for the C language. C language is very documented, very controlled, very well developed, unlike maybe Java, which is open source, so there's all kinds of inconsistencies in Java. But anyway, C is very defined. C is the basis for a lot of complex languages. So a lot of complex languages have C underneath, such as C++, where that's used to program all the video games. Not all the video games, but a lot of video games. C#. C is used, another version of C called Objective-C is used for programming mobile phone apps. But anyway, C is a very exact program. It's very powerful. It's very compact. It is very efficient in using the memory of your computer or your device that you're programming for. So let's look a little bit more about our very first program, which was a Hello World program. I have it here. It's in my Notepad++ right now. I typed it all in, but to make it a little bit bigger, I've copied it and put it over here in the PowerPoint. So let's talk a little bit about the parts of the program. This part up here in the green letters, this is the header, or it's actually called the preamble of the program, and these are comments about the program. So the comments are all green, and they're, in this case, I have it between a slash, asterisk, asterisk, slash, and that means that all of this block, this is a block comment area. This block comment is completely ignored by your compiler. It will just be completely ignored. So these are block comments. You can also do line comments, which I'll show you in a moment what the line comments look like. I think that's the first one your textbook uses, but these are block comments. If you just want to comment out single lines or put comments at an end of a line, you can use the / for line comments. So that in your programs, I require you to put this information called the preamble at the top of your program. So whatever homework problems I give you, I want you to tell me what problem number it is. I want you to tell me your name, date, and a description of what this program does, or whatever program it is you're assigned. This is required. If you don't have this preamble part in your program that you submit to me, you will lose points. I do this because this is a standard programming practice. If you go out and get a job as a programmer, your program will have to have proper commenting in it. That's just good coding practices. Next, I have a white line 6 has nothing happening in it. That's called white space. In your programs, you should never have more than one line of white space. For example, I wouldn't want line 6 and line 7 to be blank and then my include statement to be next. That would be too much white space, and it leaves a question about, it doesn't hurt your program's going to work anyway, but it leaves the question about, was there something there that you took away? Anyway, it's part of coding style. Your coding style needs to be correct and to a standard. Any company you do programming for will have a coding style that you need to adhere to. So this next statement here include standard IO.h. Just, you might have several include statements. Actually, by the end of this chapter, we'll have also include math.h. But these include statements are called preprocessor directives. They provide instructions to your compiler before the program is actually compiled, and it tells the compiler what pieces of programs that you're going to need, like using a standard IH program. Your program will use the standard IO within it, and so it tells the compiler to, when you compile this program, that you're going to compile it with the standard IO or the math or whatever it is. The .h means that they are header files. It goes outside the main body of the program. Next, we have this main section of your program. It begins with main and closed parentheses. Main means it's a function. You'll see my example here says main and the two parentheses. The example, your very first example in section 2.2 of your book has int main parentheses void. I will talk a little bit more about that. That is information that didn't really need to be there. The bare minimum right now is main and parentheses like I have it shown. The void actually means that the program isn't going to return anything. We'll learn more about that. And the int means didn't even need to be there in the program on page 2.2. Maybe I should put that up just to show you what the book has for something different. Let me bring it over here. I don't think it looks very good, but I'll bring it over. Can I make it bigger? This is from the E textbook, yes. So this is the example in the book. It has int main void. You didn't need to put an int, and the void just means that nothing is being returned by this program, and we don't return anything back to the program. We do output something to the screen, but we don't return anything back to the program. Wasn't necessary to say int main void at this point. You could have just had main with parentheses and nothing in it because it's already a void program. Then we have the body of our program. Our body of the program says printf hello world, and we have this /n, which means have the cursor move to a new line. Then there's a get character function call, and get character says wait for a character from the keyboard, and that's how we were keeping our program open. These things inside my program right now are called statements. You might also have at the beginning here something called declarations, which we're going to learn about shortly. So the declarations and the statements are all part of the body of the program. The body of the program must be in these two curly brackets. In your book also on, it says good programming practice number 2.1, bringing your book back over here for a moment. Next page of it. Oh, these e-books are a little bit slow. See, the little thing is getting to the next page. That's why I have actually a paper book too, but I like the paper book. Talk about white space, this beginning here, and then it says good programming practice 2.1. Every function should be preceded by a comment describing the function's purpose. I will make, and there are exceptions to that. Every function that you write, which you'll learn about in chapter 5, you will have to have a comment, a line comment to explain what the function does. But everybody knows what the main function does. I don't need a comment, a line comment before the main function saying this is the main function, the main body of the program. And I don't need to have a comment after printf hello world because I did the printf function. These are standard functions. They're actually keywords and you don't need to have comments for them. Okay, we'll talk a few more things about style that your textbook says, because I have a few differences from the textbook that I'm not particularly picky about. but let's look at them. I'm going to go over here to my Notepad++, which I made a little bit bigger. Textbook likes you to put an extra space here and here because it brings emphasis to what the argument of the printf function is. Okay, that looks nice. That's fine. This part right here, the /n, that's a slash new line. That, as I said, causes your cursor to go to a new line. So I could do something funny like, I'm going to do control copy, paste, hello world. I love programming, with another new line, and then my get character at the end. So let's save that for a moment. I'm going to go ahead and I'm using PowerShell. PowerShell has more power than command prompt does. Windows says that PowerShell is going to take over for command prompt, but I doubt it because command prompt is simple and PowerShell is more complicated. But right now PowerShell uses all the same commands as command prompt will do. So I'm going to use PowerShell. I like the colors. I like some of the power that I get from PowerShell. Gives me everything instead of in black and white. I get some colors. So I'm in a particular directory right now, documents/classes. But let me see where I need to be. See, PowerShell in Windows 10, I have upgraded to 10 now, gives me some colors, so I like that. So you can see my classes. The thing I like about PowerShell is it gives me my last read write times. It gives me sizes of files. I have a length of a file in here, some of my other documents that are in my directory, and over here it will tell you something about the permissions for the various documents or directories. But anyway, I want to be in EE160, so I'm going to change directory CD to EE160. And I have a bunch of stuff in there. I have this year or last year, so CD to 2015. This what's in the directory. Oops, I don't want that. CD back up a directory, so CD ... takes me back up. Whoops, made a mistake. I want to see what's in the 2016 directory, so I'm going to go to change to the 2016 directory, list what's in the directory, ls. So there's a few things in here, not a lot yet. It'll grow as the semester goes on. I'm in chapter 2, cd chpt 2, list the directory. Okay, so I have right here the PowerPoint that I'm currently working on, and the first program.c file, which I just saved in Notepad++. So I want to compile it because I made a change to it, so I have to recompile it. GCC. Now, as I mentioned, sometimes I get tired of retyping everything, so one thing I can do is just go over here, highlight it by holding down my right mouse button, then left click my mouse button and paste it right there, and then left click. Said all that backwards. Let me do that again because seems like my right and left fingers were confused. So I'm going to left button click and highlight. It's my right hand. Left button click and highlight first program.c. Right click on it. Right click down here, and it came there. It was pasted there. Space -o for make an object file, and then what program do I want to call the executable? I want to call it again first program, and I don't put the .exe here. It will do it right. And I don't have to call it first program. I can call it something else, but it's just more consistent if I do it this way. So I didn't get any red letters coming up at me, so that means I didn't make any mistake. Good for me. So now I can run the program by doing /first_. Oh, before I do that, let me show the directory. So there it is. It did make a first program.exe. It was there before too, but I changed it. And now I'm going to run the program. /first_program. Oh, don't need to do anything. Program runs, and it does say, hello world, I love programming. And it's sitting here waiting. It's not doing anything until it gets a character from me, because there's a get character function call. So I'm just going to say enter, and I'm back to where I was. Now sometimes I get tired of seeing all this junk on my screen, so I can type either a CLEAR in PowerShell. Oops, CLEAR. I just looked this up. It's supposed to work. Well, CLS works. So it works in command prompt too. Type CLS and you can clear your screen and clean it up. So let me go back now. If I did not have this escape sequence slash new line right here, and I recompile the program, save. Now if I'm pushing the up arrow key, and so I can actually go back and find previous lines that I've typed, and just by pushing the up arrow key, and I don't have to retype them. So that's what I did. So there it was. I recompiled, and I'm going to, now that I've recompiled, I want to run it. I push the up arrow to the line I wanted, push enter, and so you see I took out that one slash new line escape sequence, and everything is printed on the same line. So unless I tell my program to go to the next line, it's not going to go to the next line. There are some other escape sequences. I do suggest you try them, play with them, see what they do. I can show you a few of them. A slash T is also an escape sequence for horizontal tab. Let's see if this one works. Sometimes this works for me, sometimes it doesn't, depending on the computer I'm on. A slash A means to do a bell. Slash A. Let's see if it works. So save the program. Up arrow, recompile it. Up arrow, run it. Well, I didn't hear the bell, but oh, that may be because I have my headset on, and anyway, I didn't hear the bell. So some computers I always hear the bell, some computers I don't. I should play with that if I really want the bell, the tone. But anyway, so what if I want to say something in quotes? Make that back to be a slit. What if I wanted it to say, hello, silly world. So you see, silly is no longer red. I want silly to be printed within quotes, but I've completed this. Well, I'll show you what happens. Let me save it. I'll show you what happens if I try to make this mistake. I will make this mistake just for you. And it tells me that there's something wrong. I get some compiler errors. And it tells me what line in my code that there are compiler errors. It doesn't like it. It points it out to me right there. So how are you going to fix that? The way you want to insert a double quote like I just did is you're going to put an escape sequence there. This is going to need an escape sequence there, and now this should work because I put this slash in here that says the quote is really this is how you put a escape sequence. You put a double quote in it without being the double quote that's required around this string of characters that says hello world. So save it, confirm that it works. Oops. Yeah. I didn't get a compiler error. Let's see that it does work indeed. And yes, it says hello silly world. I love programming. Good. All right. So that's about escape sequences. Okay, here's another one. I just changed it a moment ago. Here is a sequence of text characters with escape sequences in it. What do you think this will print? Taking a look at that. Let's try it and see. Recompile. Rerun it. And so those slash T's in there were tab, telling the cursor to tab over. So looking back at the program, 5/T means tab, 4/T, /4, then tab, 3, then tab, 2, then tab, 1. Now I don't like the way that's written. The compiler understood what to do with it, but it would be much easier for me to see if I actually did it this way. But there will be a slight change to the output, which I will show you in a moment. So to me that's easier to read. I'm saying 5 tab over, 4 tab over, 3 tab over, 1 tab over. But I did insert an extra space for readability, so let me see what happens there. Compile it again. Run it again. Oh, it didn't insert the extra space. We are okay. That's right, it would not. But see, so sometimes if you're not sure what the output would be, just try it. Make sure in your programming that you like what the output's going to be. That's the way programming is. Try it, try it, try it, try it. Okay, so now we showed how to print something to the console by the printf, but F, by the way, means formatted. So print formatted, and then something in the argument of this function. But we're going to now learn how to accept input from our console window or our keyboard with the scanf, which means scan formatted functions. These are built-in library functions in C, which there are available by default by all your they're available by default in the C library. The way that they are made available by default is because you wrote that include statement at the beginning of your program that said include stdio, which means standard input output, in your header as a header file. So you have to put the include standard IO in the C program to make use of the printf and scanf library functions. So let's look at a program. It is very similar to your example in section 2.3, but I did change it just a little bit, just so you have something, makes you have something different to look at. Here's the program. Keep in mind I did put my header information up at the top, preamble information. I did my include standard IO, and then I have this body of the program going on right here. But we have some different things that happen. So the first thing I have, I talked about that I was going to show you next to show declarations. I have made some declarations right here. Basically, I'm defining a variable. That's where I'm declaring my variable. I'm calling a variable number 1, and its type, its data type, is int. Now you have to, every variable that you define in a program, int means integer. Every variable that you define in a program, you have to give it a type, whether it's a floating point number, integer. I'm going to go over data types here shortly, but you have to give it a type. C is what we call a strongly typed programming language. Then you know the printf function. Get the first number, I tell the user. But then here we have the use of the scanf function. And I'm going to talk a little bit more about the format of it. So you have a scanf, you have something that's going on right here and something that's going on right here. You can kind of guess what the rest of the program does. Get the second number and then calculate a sum and output the sum. So I've already compiled this program. So you could, it's in this area, actually you can see when I ran it, example 2.3, it says get first number, I entered I'll run it again. Run it again. Get first number 6, get second number 8, and the sum is 14. Just to show you something else, I'm going to run it wrongly. Get first number 5.9. Get second, so it's messed up. See, something didn't work right. So you have to be very careful and very exact in your programming, but we'll go over that. Okay, so let's talk a little bit more about what's happening using the printf and scanf functions. I'm going to take one line of that code, the scanf function, the scanf line, and talk about what's happening. So I said scan formatted, and then I have a portion here in double quotes, like a text thing, but it's really saying you're getting something, a string from the keyboard. It's in something that has, this is a format control string, so it says get something from the keyboard with a certain format. Your textbook example used a D, which means decimal integer. In my example in Notepad right a moment ago, it said %I for just plain integer. I'll show you. See, mine says %I for just plain integer because I declared an int up here. More about that coming. So back to the PowerPoint. And then I have a comma, and then I have an ampersand number 1. So remember we declared a variable called number 1 and we said it was an integer. Well, number 1 is really the name of an address in memory. So somewhere in your computer is a memory location, and I've kind of giving it a name, kind of like a tag of saying that memory location is called number 1. And the ampersand is what's called an address operator, and it's basically saying get a number from the keyboard. It should be formatted as a integer. In this case, D is a decimal integer, and store it in a location in your computer that I'm going to call number 1. So it specifies a memory location with an identifier not name.length with the identifier number 1. So that memory location is identified by number 1. That's the identifier. So there were a little bit of ways I could have done this program more efficiently. Another thing is before you can use, like before I can use sum, before I can ever use it in a program, I have to declare what sum is. Sum in this case is an integer, is a variable with an identifier called sum, and the type, the data type, is integer or int, int. I could have written this a little bit more efficiently. Usually data types are declared at the top of the main body. Your declarations are at the top of the main body of the program, and if my data types are the same, I can make it a little bit more efficient. So I'll show you. By the way, it's a good idea to put a space after your comma. So I'm going to declare number 2 there. Get rid of that line of code. Clean it up a little bit. And sum is also an int. I'm going to get rid of sum, that declaration here, and I'm going to declare it, comma, space, sum up here. So I have made it more efficient. I don't see really, oh, there's one more trick I'll show you. So the code is looking more efficient, which is good. This will run the same way. Now, if I have some different data types, I have to give a different line of code for its declaration. The other thing is things go in order in the program. If you want the program to first give a message to the user, then accept the input from the user, it has to go in that order. Probably figured that already. Then finally, I have the printf command, and another fun thing happens. I say the sum is, and then I put this notation here, this format specifier in. And the way it works is that, and then I put the variable comma and then the variable name. The way it works is this variable name sum is going to get substituted to that value in the string with this format specifier embedded in it. So I can give you another example. The sum is, substitute in value of sum right here. Let's take out the new line. And the first number is %I, and go over here and say number 1. Notice Notepad gives me some nice lookup there. Okay, so now what's going to happen is the first time I see %I, or %I, the value sum is going to get substituted. And then the second time I see it, the value number 1 will get substituted. So let's try it and see. Save. recompile. Remember, I'm always pushing my up arrow every time. Compile it. Get first number, 5. Enter. Get second number, 4. Enter. And it says the sum is 9 and the first number is 5. Oops. And then I have my next line of my prompt showing right away. Because why? Because I forgot to put a new line / new line right there and make my cursor return to the next line in the console. Here is an example of different conversion specifiers. I say conversion because they will also do some conversions that we'll talk about in a bit. But basically they are also format specifiers. So you can see some of the examples that you have. An int is either a %i or a %d, and then we'll talk a little bit more about others. You can be expecting a character, floating point numbers, double precision floating point numbers, long floating point numbers. There's unsigned integers. I'll get you some more. I'll show you more what they mean as we need them. So now section 2.5 talks about assignment operators. Our math operations, most C programs will do some kind of a math operation or some kind of arithmetic. Our math operations, we don't say equals, we say a variable is assigned something. So here's a list of a few operators that I'm going to go over, and then I'm going to show you a more comprehensive list. So assignment operators. So for example, we made a declaration int x equals 1. We can make this declaration y equals 2 and z equals 3. Actually, it's x is assigned 1, y is assigned 2, and z is assigned 3. Even more formally, the memory location with the identifier x is assigned the value 1. The memory location with the identifier y is assigned the value 2, etc. So that is the assignment operator. An equal sign is an assignment operator. We have, of course, an addition operator. We have a multiplication operator is an asterisk, and a percent operator is not a percent sign, but that one will give a remainder. Another thing I guess your text doesn't talk about, I didn't see it in your textbook, is this kind of an operator is called a unary operator, because it means that x gets whatever the value of x is right now plus 11. So x was 1, so x becomes 12. It's unary because there is only one variable to the right of the assignment operator. Z++ actually means add 1 to z. So when you see plus plus, it's increment by 1. So z was originally 3. Z++ means z is now 4. Z plus equal means, x plus equals 3 means to add 3 to x and then make x equal to that new value. So you look at that and you say, what is the current value of x? X is currently, did I do this sequentially? I might have done it sequentially. Yeah, x is currently, see, as we were going through, I'll redo this so we're here on the right so we can just go through them, because it's kind of fun to do. In all honesty, it's kind of fun to do. Guess I shouldn't have left that in there, so we'll do it. We'll go through it. So x gets x is assigned x plus 11. So x is 1 by our original declaration. So x now is going to get assigned the value 1 plus 11. So we know that the value of x is 12 right now. Y gets y plus 5. That's easy enough. So y currently becomes a 7. Z++. So plus plus means increment by 1. So z is currently 3, so now z will be a value of 4. Z plus equals 3. X plus equals 3. So x is currently 12 if we were in a program. So I'm going to add 3 to it. So 12x will now get assigned the value of 15. And then finally, w equals x times y. X is 15. Y is, the current value of y is 7. So whatever that is comes out to be, will now be the value of w. And you should check that if you were programming. This is multiplication. This means remainder, which we will look more on remainder a little later. I'll show you some more operators. Now, one thing you've probably learned in math, that multiplication is done before, multiplication and division are done before addition and subtraction. That's called precedence. Precedence of arithmetic operations. And then the parentheses, of course, are done before, earlier than the multiplication. So programming is very precise. You can really mess up if you don't pay attention to what that precedence is. Let me show you the full precedence of operations. Your book has a subset, but I'm going to show you the full one from the Microsoft website. So if you go to msdn.microsoft.com, there's a library all about C programs, because C is a standardized program. But if you go on there, and I'm sorry it's hard to read, this is the order that a line of code will be executed in a program. So it does have multiplication and division, goes from multiplication, division, and the remainder sign, the percent sign, are done from left to right. They are done before addition and subtraction, and then there's some other things that occur. It's done before equality, which we'll learn about that. It's done before logical operations, which we will learn about that. But there is a complete list here. And by the way, look, parentheses are done first. I'm sorry this is a little bit tough to read. Let me expand. Not very well. But I do suggest that you go to this website right here and look at the full order of precedence, although your textbook does a pretty good job talking about it. So I've changed my example a little bit to show you something that happens if you don't pay attention to the order, the precedence in the program. So I have again I have variable declarations of number 1, number 2, and answer. And so I'm going to get the first number, store it in number 1, get the second number from the user, store it in number 2. And my answer is going to be a formula here, number 1 plus number 2 divided by 2. And then I'm going to go ahead and print the answer. So there are a few problems with this program, and I'm just going to do it by example. So the first problem, let's run the program. Actually, let's decide what we're going to do in the program, and then we'll run the program. We'll do our test. Let's say the first problem that we want to do, for example, maybe let's say that what we really want is the answer to be something like a number 1. If this is what we want, an average of 2 numbers, this would give us the average of 2 numbers. But we typed the code in that I just put, we will not get the right answer. So this will give us an average. So let's pretend we want our program to find an average of 2 numbers. There's an additional problem, is that I've declared everything as an integer, so it's going to be a problem. Let's try this example out first. So here's our first example. There was our code, and I made a mistake right here. I didn't pay attention to my precedence. So what will happen is I'll get the wrong answer. But let's do it. Recompile. There. Recompile the program. Run it. Get first number. Let's say I'm going to get the average of the numbers 4 and 6. So the average would be 5. 4. Get second number 6. Enter. The sum. Oh, did I not read? I didn't save it. That's why. Okay, let's go back and save. I changed the program and didn't save it. Save. I can make all the so I have another mistake. It didn't compile correctly. Where is my other mistake? I can make all the mistakes and then you can look out for them because there, I see it. Shouldn't have been like that. I can make all the mistakes and then you'll know what they look like when you see them. Compiled okay, good. That means I did all right. Get first number 4, enter. Get second number 6, enter. And the answer is 7. No, the average of 4 and 6 is 5. So what did I actually really calculate? Because I entered the code wrong. What I really did was answer equals 4 plus 6 divided by 2, which turned out to be 4 plus 3, which is 7. So because I didn't enter the code correctly, this is what it calculated. So the correct way to have done that in the code would have been to put parentheses in. And then I would get the correct answer. But there is an additional problem with this program, and I'll show it to you in a moment. So save. That will give me the correct answer. The problem with this program is that my variable types are all integer. So what if I wanted to average 4 plus 5? The answer should be 4.5. But let's try it and see. Get first number 4, enter. Get second number 5, enter. And it says the answer is 4. Well, is the average of 4 plus 5 4? No, it's not. But the reason is that I've declared everything to be an integer, so the program doesn't know what to do with a decimal. So a decimal number or a fractional number. So what we would really need to fix this problem is declare this a different data type. Let's go ahead and try one. So if I say that, then I have to make everybody match. Changing all my formatting codes to be floating point numbers. So floating point numbers are numbers that have a decimal point. So let's try that. Actually, I don't even like to do that. I want to call them all doubles, double precision numbers. I think that will be correct. Let's run it and see. There will be a further discussion on this in another YouTube. Get first number 4, get second number 5, and the answer, still a problem. Okay. So, my bad. So I declared everybody to be double precision numbers, and then my format codes have to be LF. F by itself won't work. LF, and they're all LFs. And then when I compiled and ran the program, first number is 4, second number is 5, and the answer is 4.5. This little thing with the declaring doubles and LFs may get you if you're not careful. More on that in a later time. Well, I probably would have done this next section later in the next chapter because controlling and making decisions in your program actually happens more in the next chapter. But this section went ahead and introduced an if statement anyway, so we'll talk about it. So equality and rational operators, before we had the arithmetic operators, add, subtract, multiply, divide, percent signs, parentheses being very important. But now we have these equality and rational operators, and they'll be used to help control our program. So in math, these are the symbols: less, greater than, less than, greater than or equal to, equal and not equal. But in the C programming language, they're not quite the same. For example, if you want greater than or equal to, you type a greater than sign and an equal sign, and there better not be a space in between or it won't work right. If you want to test if two items are equal to each other, it's not an assignment. You're going to test if two things are equal. You're going to type equal equal, like saying it's a test. If x is equal to y, for example, there'll be a test. It's not assignment. I can say x equals y, and then x will get assigned the value of y. But x equal to y is a test. It's a test for equality. And then this is not equal. So not equal, you would have to put an exclamation point in front. So this is how you would express it in C. Here's an example in C, but I'll show you some better examples here. Okay, so I have an example to show you these equality and rational operators. So I've declared two variables called a and b, and I made them integers, and then I asked the user to give me two integers. But please notice how I asked the user to give me two integers. It's kind of nice here. I said scanf, and I asked for both of them. So %i, store the first one in A, store the second one in the memory location identified by B. Then I put a line of white space just to make things more readable, and then let's introduce this if statement. So the structure of if statement, and we're going to learn a lot more coming up, if else and which and switch and a lot more. But if A, and I like to say if A is identically equal to B, and then the body, this is called the body of the if statement. The body of the if statement is going to be in curly brackets. Notice there is no semicolon here. Like the ends of these lines must have semicolons, right? But there is no semicolon after the if statement. You have to have two curly brackets to enclose the body of the if statement, or what's going to happen if the if statement evaluates to be true. So what you're doing is saying if, and then here is a test. If A is identically equal to B, then you're going to print this statement. But if A is not equal to B, you're not going to do anything because I didn't give you any other alternatives. You're just going to go on to the next portion of the code, which I do another test. I say if, and here's the condition, if A is not equal to B, then I'm going to print a different statement. So the code is going to go through sequentially, and only if these if statements evaluate to be a true, then will whatever's in the body of the if statement be executed. So that's how the if statement works. Introduced a little bit prematurely, but that's okay. Let's save. This program is already saved, and compile it. Especially so you see this scanf, how it works when it looks like a running piece of code. Compile, run it, enter two integers. Keep in mind that they have to be integers. So 6 is the first one, 8 is the second one, and they're not equal, and the second number is bigger. So it indeed works. You can write the program for yourself and test and play with it. So you have to be careful. In this program that we just had a moment ago, this program that we right here that we just had a moment ago, we named these variables A and B, but there are some rules to naming the variables that we have to go over. And by the way, you could also have a constant. I'm going to show you a constant. Let me show you the constant first. So I wrote this little program. I have a variable A, a variable B, and then I have a constant, which I call factor. And it happens to be a data type double. So factor equals 10.5. So I ask the user, please enter two integers. I get integer 1, store it in A, integer 2, store it in B, and then I print a calculation. Here, notice my little shortcut here. I say the result is, and then I have this format specifier here, but I say the result is A times B times factor. So you can do a calculation here in this part of the statement, and that the result of that answer will go directly into that place where that placeholder is in the string. So that's my little program. But there are some rules to naming either these variables or these constants. So let's look at what those rules are. So constants are specific values like pi, 2 point, no, or like a number. That's not pi, is it? A particular character, a particular string, a particular number. And they're also stored in memory. And variables are also stored in memory locations that are assigned a name. Both of these are assigned an identifier, but there are naming rules to these. Well, a constant, of course, is something that doesn't change throughout the program, like I just showed, like the factor. It's not going to be changed during the program. So there are rules and there are style rules. There are rules that if you break these rules, the program won't compile. And then there are style rules, which are part of our style conventions. So rules are the identifier must begin with an alphanumeric character or an underscore. I don't really like the underscore method style. It may contain digits, but not the first character. The first character cannot be a digit. And it can have upper and lower case, and those will be valid names of identifiers. But the styles for our coding style is that a constant should be named with all uppercase letters, and a variable is all lowercase levels. Level begins with a lowercase letter, but in particular it should be what we call camel casing. So that means like the words in between have a capital letter. So for example, temp C or femur length. Notice how the L for length is capitalized. It's called camel casing because it's like a hump in the middle of a camel's back. There's electron charge and length side 2, perfectly valid to put a number in the name that I name my variable or my constant, the identifier. But there are some rules, some words that absolutely can't be your variable or your constant identifier. And here they are. They're called keywords. You cannot name your variable any of these words because they are words that have special meanings. We learned a few of them already, like we learned an if statement already. We will learn a lot more. But these are keywords that you cannot name. Also, the data types, like character is a data type, char, or should be listed in here, like our double is a data type. It's a data type, but it's a keyword. Float is a data type, but it's a keyword. You cannot name any of your variables with these words. The last little thing this section of your this chapter of your book mentions, and there's a lot of information in this chapter too, is that for they say it's for security reasons, but they didn't really explain why it's very secure. But it has to do with getting hacked and attacks and there being a new line. We'll learn more about it later. But instead of using printf to print a single line of code, or a single string, we have a single string right here, and having to put always a new line at the end of it, what the book suggests is a better practice is to say puts, and then take out the new line, and the other one is puts. Puts there, but this one should still be printf. The reason this one's still printf is because I'm using some format specifiers in it, but this is just a plain old boring single line string right here. So book suggests you use puts. Let's just make sure that all still runs, because I actually didn't try it before in this example, so I will try it. Yes, it looks okay, and run the code, enter 2 integers. I always check everything to make sure it works. Yes, okay, no problem. This ends chapter 2. This YouTube was a little long. More in another YouTube.